Good morning, everybody. I wanted to speak to you a minute today about word problems and equations and how they might work together. So this scenario is similar to the one in your book, but a little more applicable to my family. Let's say I'm working on summer plans for 2021. I'll be perfectly honest, I'm not working on 2020 plans yet because it's due up in the air. So for 2021, I want to go see some baseball. I miss baseball. I like baseball live. So I want to take my family to see some baseball games. Once I get done with school and start getting ready for school, we have about 9 weekends in the summer where we could do this. So I set aside a budget, and I know that I have 9 weekends, so I could pick a Friday, Saturday, or Sunday game. And I know that parking is $20. Well, then what budget do I have to spend on tickets? Am I at River Cats on lawn seats? Can I make it to a Giants game? What's my budget? What can I do? The nice thing about equations is it gives you that flexibility. If budgets change or if the number of games you want to go to changes, you don't have to redo all of the math. So let's look at this. We know that we have a total, and we know that the total needs to equal the game plus the parking, and we know that there's probably going to be 9 games. Okay. So let's make the variable to be C. C equals cost of tickets, or cost of the game. Okay. And now let's kind of fill this in. Notice I just talked it through first. I didn't worry about any numbers. So I'm going to say that $945 is equal to the cost of the tickets plus 20. I have to spend that every single game times 9 games. Now, I can go after this a couple different ways. I could use distributive property, or I could use the fact that the 9 is already factored out. Let's look at it both ways just for practice. Okay. So just for practice, I'm going to rewrite it down here so it's a nice clean copy. And we're going to do it 2 different ways. Now, a lot of times you'll see the 9 in front of the parentheses, probably a little better manners. Sometimes you'll see the total on the other side. This would have been flopped. Okay. But I'm purposely writing it a little bit differently, just to give you the experience of they don't always look the same. Okay, so exact same equation. We're going to solve it 2 different ways. This first time, I'm going to see how much it costs, basically, per game. I'm going to distribute. So $9.45 equals 9C. 9 times 20 is 180. Well, now I'm solving an equation, so my goal is to isolate the C. Subtract 180. Subtract 180. Okay. 9C is 14, 6, 8, 7. Notice I don't do it any different than you do. Okay. Now 9 is still hanging out with C. Instead of multiplying by 9, I need to divide both sides by 9. So 85 equals C. So I have $85 per game to spend on tickets. I can take myself all by myself for a decent seat for $85. Maybe I could find a family pack for $85. But I know what my budget is for tickets. Okay. And then if I wanted to buy, say, 5 games worth, I would know what that is. So I could just take that ticket cost and multiply it by however many games. Now in this scenario, since I already know I'm going to 9 games, I'm going to get rid of this number, this factor, by dividing from the very beginning. So instead of distributing the 9, I'm just going to divide both sides by 9. So now I have C plus 20 equals 105. Now, C is still hanging out with 20. The opposite of plus 20 is negative 20 on both sides. And C equals 85. Same solution no matter which of the choices that I use. Hopefully that's very helpful to you and gives you some application of why we